Hello everyone, today I am going to discuss the fourth problem of AtCoder beginner contest 266, which is Snook Panic. So we are given 5 pits, and their in Snook will appear from the pits, and they will appear. Ith Snook will appear at time ti, and at the xi pit, and the size of it will be ai. Now Takahashi at his coordinate 0, and he can either move right or left at speed of 1 coordinate at a time, and he can catch a snook appearing from a pit only if he is at the coordinate at the desired time. The time it takes to catch a snook is negligible, and we have to find the maximum sum of the sizes of snook that Takahashi can catch by moving optimally. So the constant is very important here. The first and the most important constant here is the constant on x. X could be from 0 to 4. So let's solve this problem. What we can do is that Takahashi is at, let's say, his coordinate is, let's say, x. So Takahashi is currently at 0, and the time, let's say, t is also 0. So let's say this is as a recursion state. Okay, so x comma t is the recursion state. So where you can move from this recursion state, so there are three possibilities. So let's say time t is equals to, so time, 1 unit of time will take from move. So we can either move to right, so it will be x comma t plus, sorry, so we can either move to right, so the coordinate of x will increase, and the time will obviously increase because we are moving. Or we can either go to left if it is possible. So if it is possible or not, we will check it in our code. So x plus 1 and it is t minus 1, or we can go to x comma 2 t plus 1. So we are staying at the current position, this is also possible. So let's say Takahashi is currently at x comma t, and there are, let's say, p number of snooks at that time at coordinate of x. So we'll take the sum of values of these snooks. Okay, so let's say Takahashi is at coordinate 1, and at time, let's say, 5, and there are 10 other snooks x1 x so whose xi is equals to 1 and ti is equals to 5. So we will just take the summation value of these snooks. Okay, so let's go into the solution now. This problem is quite straightforward. So we are x comma t, as I have explained, the coordinate and the time of Takahashi. So if is x less than 0, this is invalid case, or x equals to 5, so we are just at our lower bound or upper bound, or t is greater than maxi. So what is maxi? Maxi is the maximum time of a snook. So we are given an array of snooks. We will just take the maximum value of all ti's. Okay, that is maxi. So if it is at our lower bound of x or upper bound of x, or our time is greater than maxi, then we will return 0. And we are doing just memorization here. Or we can dpxt is sum of x comma t. Sum of x comma t is just a map of array of length 2 to length. So sum of x comma 2 t will give us the sum of all snooks which are at x at position, sum of ai's of all the snook which is at coordinate x at time t. So, and we are taking x minus 1 comma t plus 1, x comma t plus 1, and x plus 1 comma t plus 1, as I have explained here, these three cases. So we are just taking the recursion maximum of these three values, and at the end we are returning dp x comma t. And this is quite simple. I will give the link of the code in the description box. If you still have any doubt, you can ask me in the comment section. I will reply all the comments. Please like the video and subscribe to my channel. Thank you.